Okay, so like we just discussed the occluded stage. What's the occluded stage? Is when that cold front caught up with the warm front. Okay, that's the occluded stage. But now the interesting thing about this, we have two different types of occlusions. Okay, we have a warm front occlusion and we have a cold front occlusion. And it's so simple. I'm going to show you now. Especially, I want you to rather use diagrams if you need to explain the difference between a warm front occlusion and a cold front occlusion. Use diagrams. And I'm going to show you it's extremely easy. Okay. The only difference is the coldest air, the coldest front, the air behind the coldest front attaches itself to the surface. Yes, this sounds wild. It sounds intriguing. It sounds interesting, but it sounds confusing as well. But have a look at this. Okay. So that cold front is caught up with the warm front. Okay. But the first one I'm going to show you is just want to use a different color pen. The first one I'm going to show you is a cold front occlusion. Okay. I'm going to write it down there because if you're making notes at home. So what happens? This cold front is caught up with the warm front. Okay. So what does it do? The cold front attaches itself to the surface and the warm front attaches itself to the cold front. Now, why does this happen? Because we have three different types of air masses. Now keep in mind, this is the cold front. Because the air behind the cold front is very cold. Now remember, all the warm air has been displaced because this cold front is caught up with the warm front. This is the warm air. As you can see, there's no more warm air on top of the surface. All of it's been displaced. As you can see, this used to be the warm air, but the cold front is caught up with it. So it displaced all the warm air. But when we experience a cold front occlusion, the air behind the cold front is extremely cold. It's very cold. The air in front of the warm front is only cold. Okay, so where will we experience the coldest air? Usually closest to the surface, because why? It's denser, it's heavier. Okay, so the coldest air is closest to the surface. And where did we find the coldest air? Behind the cold front. So the cold front attaches itself to the surface. I'm going to write it there. We have a cold front occlusion. This is going to sound let's have a look at it. A cold front occlusion is when the air behind the cold front is colder than the air in front of the warm front. Now that's the reason why it sounds confusing. If you need to read this out to your mate, you're probably going to say, what the hell is going on here? But let me show you how easy it is by referring to the diagram. So if they want an explanation in the exam, don't even think twice. Go and draw the diagram. Okay, it will make it just so much easier to explain. So have a look at this. Now, for instance, when the air behind the cold front is colder than the air in front of the warm front. Now have a look over here. The air behind the cold front is colder, very cold, than the air in front of the warm front. So what happens? We can add there. So, don't write so, but just saying. So the cold front attaches itself to the surface. Okay, so that's a cold front occlusion. Now remember, look at the diagram. I hope you've copied the diagram because this is basically the concept of it. But to understand the concept, the diagram explains it so much easier. Okay, but let's continue. Let's do the warm front. Okay, so we have our warm front occlusion. So once again, I'm going to start out with my diagram, explaining it to you. Okay, so the cold front is eventually called up with the warm front. All right, so let's say that's the cold front. All right, but pay attention. With the warm front occlusion, the warm front attaches itself to the surface. Okay, look at the difference. There's the warm front attaching itself to the surface. With our cold front occlusion, it attaches itself to the surface. Now, what's the reason for that? Remember, where are we going to find the coldest air? Closest to the surface. Okay, you jump into a swimming pool. Where do you find the coldest water? On the bottom of the swimming pool, closest to the surface. Okay, and let's go back to our diagram. Now, what do we have here? We have a warm front occlusion. The simple reason why is because the air behind the cold front is only cold. Now remember, all the warm air has been displaced because the cold front caught up with the warm front. But what happened over here now? The warm front attaches itself to the surface because the air in front of the warm front is colder than the air behind the cold front. So I'm going to write it out, and then we're going to have a look at our diagram. It's when the air in front of the warm front is colder than the air behind the cold front. I mean, if you read it, it's absolutely confusing. When the air in front of the warm front is colder than the air behind the cold front. Now, let's have a look at it. When the air in front of the warm front, it's this air, it's in front of the warm front, is colder than the air behind the cold front, it's known as a warm front occlusion. So what can we say is the warm front attach itself to the surface. Wait, sorry, I made a spelling mistake there, stupid one. Okay, so that's the difference between a warm front occlusion and a cold front occlusion. Now what's going to help you over here, just pay attention, I just want to repeat myself. The cold front attaches itself to the surface because the air behind the cold front is colder than the air in front of the warm front. If you look at this area over here. Now, when we look at the warm front occlusion, the warm front attaches itself to the surface because the air at the warm front, in front of the warm front, is colder than the air behind the cold front. Okay, so hopefully that answers your question. Okay, let's move on. Okay, so that was mid-latitude cyclones. Hopefully you can distinguish the difference between cold fronts, no, mid-latitude cyclones and tropical cyclones. Remember, mid-latitude cyclones have the warm and cold front attached to one another. Tropical cyclones, perfectly shaped round isobars, warm conditions. Think of tropical. Okay.